Scatter plots. Alright, so for our vocabulary we have scatter plot, which is going to be a graph that just has points plotted on it. It's going to show you a relationship between two variables, but there's not an equation like we've been using. There's no linear equation, there's no line. It's just points on your graph. Okay. Correlation is talking about the relationship between the two variables. So if they both increase together, there's probably going to be some positive correlation between those two. All right. And then the line of best fit, this is a linear equation, and this is the linear equation that best fits your data in your scatter plot. Okay. So if you had a scatter plot that looked like this, this would be the line of best fit and be really close to your data. Okay? Alright, so now we're going to be looking at describing the type of correlation we see in different scatter plots. Alright, this table shows us pretty much, well, I guess not quite all of them, but most of the different types of correlation. There are two parts to correlation. One describes the direction the data is going. Okay, so you can see this is positive correlation. Okay, my line is going up. My slope is positive. Okay, same thing here, positive. All right, and then here I've got negative correlation, meaning it's falling down. Okay, with positive correlation, both data sets are rising at the same time. With negative data set, or with negative correlation, one set of data, right, my x-axis, my x is increasing while my y is decreasing. Okay, so they're opposite. All right, the other part of describing correlation is talking about how close the data would fit to your line of best fit. Okay, and so these blue lines in here, those are all the lines of best fit. All right, if your data is really close, you have a strong correlation. Okay, so my data is really close to my line, and my data are going upward, so I have strong positive correlation. All right, here my line's still going up, so I have positive correlation, but instead of my points being really close to my line, they're a little bit further away. Okay, this would be weak positive correlation. Here, same thing. My point's really close to my line, but it's going down, so that'd be strong negative. All right, weak negative. We don't usually use this term moderate, and it does make it a little bit hard. It's kind of a opinion over whether something is, weak or strong. But generally, if you've got a lot of data points really close to the line, it's strong. If you've got points that are spread out, so there's a lot more space between them, it's going to be weak. And anything in the middle is kind of a call that you can make. If you want to use moderate, you can, but generally we'll just be sticking to strong and weak. All right, and then the last one is no correlation. Okay, there's no consistent increase in one value when the other value increases, or decrease when the other value increases, so there's no correlation. Those are just kind of random points on the scatter plot. All right. Okay, let's look at some examples. So we don't have our line of best fit now, okay, but you can still see that these tend to go upward, and I would actually say that this is a pretty strong correlation. Okay, almost all of these points, if I go from one to the next, when I increase in my x, are going to increase in my y. Okay, they're all kind of going up. This one might be a little bit weaker, but I would say this is still strong correlation, but this would be strong negative correlation. Okay, this would be no correlation. All right. Okay, so now we've got some labels. Now we actually know what our data is talking about. So this is weight versus exercise, and the exercise we have is kilometers run per week. All right, and you can see that we do have a tend to go down, right? So we have a larger weight, a greater weight, correlated with a lower amount of running, okay, which kind of makes sense. It is weak, though. I would say this is a very weak correlation, and partly that is because I think this isn't a very good, there's not a lot of correlation between weight and kilometers run, because you could have a very small person, right, who doesn't run at all, okay, and they might end up down here. Or you could have a very large person who runs a lot, they're not fat, but they're just large, so they weigh more, okay? You can think of like The Rock, okay? He's in very good shape. Maybe he runs a lot, maybe he doesn't, but he is going to weigh a lot, okay? So I don't think this is a strong correlation. This would be a weak negative correlation. All right, and here we have, I think we're looking at trucks or some vehicles. So we have the weight of the vehicle and the amount of horsepower it has, okay? I would say this is a strong positive correlation, right? Pretty much always when we increase the horsepower, it gets heavier, right? And that's what you're going to be doing. You're going to be looking at these graphs. You're going to be deciding what type of correlation they have, okay? Or if they have no correlation at all.